For over a century, scientists argued about what killed the Neanderthals: war, disease, climate, competition with us. The theories piled up, but none truly explained how a species that thrived for 300,000 years simply vanished. Then geneticists began reading their bones, not with shovels and brushes, but with gene sequencers. And what they found changed everything. If you want to understand what really ended an entire branch of humanity, stick around. Because the smoking gun isn't a weapon or a plague. It's something far more insidious. Picture a laboratory, decades after these bones were first discovered. Fragments that sat in storage boxes, catalogued and forgotten, were examined again once technology finally caught up. When researchers cracked open the genetic code locked inside them, the DNA told a story no one expected. Here's what jumped out immediately. Massive sections of chromosomes were perfect mirror copies, left and right identical. If you know genetics, that's alarming. If you don't, here's the simple version. This is what happens when a population becomes dangerously small and relatives reproduce with relatives. Not occasionally, constantly, for thousands of years. The scientific term is extensive homozygosity. The human translation is, they were running out of genetic options. And this wasn't one cave, one valley, or one unlucky tribe. Remains from Spain, Croatia, and Siberia. Different eras, different landscapes, all showed the same devastating pattern. Neanderthals were trapped in a demographic vice that kept tightening. Let's talk numbers. When geneticists calculate effective population size, the number of individuals truly contributing genes to the next generation, modern humans show tens of thousands. Neanderthals? Often just hundreds, sometimes fewer. Our family trees branched outward. Theirs collapsed inward. Why does this matter? Because small populations are fragile in ways that don't show up until it's too late. Imagine a band of 40 people in Ice Age Europe. A harsh winter hits. A hunting accident takes your best tracker. 3 children don't survive the cold. A crucial elder dies. In a large, connected population, these losses hurt. In a group of 40, they're catastrophic. And Neanderthals weren't one struggling band. They were dozens of struggling bands scattered across continents, separated by mountains and distance, rarely exchanging members. Little islands of humanity that couldn't help each other when things went wrong. The chromosomes capture this isolation. Y chromosomes that barely diversify, maternal lineages that narrow instead of branching, and cave sites preserving entire families buried together. Mothers, fathers, siblings, cousins. They lived together, died together, and seldom mixed with outsiders. Then Homo sapiens arrived between 60,000 and 45,000 years ago. And here's the turning point, the part we misunderstood for decades. This wasn't a story of conquest. We didn't destroy them with superior weapons. We arrived with something more powerful, extensive social networks. We traded obsidian across 500 kilometers. We shared innovations between groups that never met in person. When one band struggled, others absorbed them. Our gene pool was an ocean. Theirs was a shrinking pond. Did Neanderthals and modern humans interact? Absolutely. You probably carry Neanderthal DNA right now. But here's the crucial detail. Early interbreeding happened. And then it stopped. In the final millennia, the genetic lifeline that might have rescued them simply faded away. Meanwhile, the climate shook violently between extreme cold and rapid warming. Herds moved hundreds of kilometers. Large networks adapted. Tiny isolated groups starved. As more genomes were sequenced, the picture sharpened. Some individuals were so inbred, their parents were likely close relatives. Genetic diversity was collapsing in real time. Women moved between groups, evidence of attempts to maintain connections. But the threads weren't enough. The circle kept tightening. So what killed them? Not a single cause. That's the point. Take modest competition for resources. Add unstable climate. Add possible exposure to new diseases. Alone, each of these pressures is survivable. Together, hitting populations already reduced to the hundreds, they become fatal. Geneticists call this a synergistic collapse. Multiple pressures that wouldn't kill a resilient species become lethal when population size is already critically low. Neanderthals didn't disappear from one dramatic event. They were eroded by demographic math. Their last refuges, southern Iberia, isolated peninsulas, mountain valleys, tell the same story. Births continued, yes, but deaths continued slightly faster. And when your entire species could fit inside a football stadium, a difference of just a few percent seals your fate. Think of those final winter camps. Every healthy adult mattered. Every child who reached adulthood mattered. A broken leg, a sudden storm, a migration of prey. Events that large populations absorb were events that small populations died from. And help rarely came, because every neighboring group was just as vulnerable. Ancient DNA preserves rare hints of what might have been. A young woman with a Neanderthal mother and a Homo sapiens father. Cave layers showing extended families fighting to maintain connections. People navigating impossible odds. These fragments remind us that their story wasn't a straight march toward extinction. It was a struggle, a resilience carried across thousands of winters, in shelters lit by fire, surrounded by uncertainty. They adapted, they traveled, they cared for one another. They survived far longer than most species ever do. But some battles aren't lost in a moment. They're lost slowly, in the quiet arithmetic of population decline. And that's the uncomfortable truth written in their nucleotides. They were too few for too long. When our large, interconnected species arrived, the contrast became existential. Survival favors numbers, communication, exchange, and flexibility. Neanderthals had strength, intelligence, and endurance. But the mathematics of survival had been stacked against them long before we entered the picture. Still, there is something deeply human in their final chapters. Imagine the last generations watching the world change around them. The climate shifting, the animals migrating, and strange newcomers appearing who looked like them but behaved differently. Imagine parents teaching children how to knap stone tools, how to track herds, how to endure the cold, all while unknowingly standing at the edge of their species' final horizon. Extinction didn't come as a dramatic blow. It came quietly, invisibly, as each isolated group vanished, leaving fewer voices to carry their lineage forward. But their story didn't end entirely. They live on in us, literally. Their DNA threads through our genomes, influencing our immune systems, our biology, even subtle aspects of our appearance. They remind us that humanity wasn't a single straight path, but a braided river with channels that merged and others that dried away. When we study them, we're not looking at distant, alien cousins. We're looking at family. And maybe that's the most humbling message their disappearance offers. Species don't survive because they're the strongest or the smartest. They survive because they remain connected, adaptable, and numerous enough to withstand the randomness of life. Neanderthals show us how thin the line between survival and extinction really is, and how quickly that line can shift beneath our feet. If this changed the way you see human evolution, hit that like button and share this with someone who'll be equally mind-blown. And tell me in the comments, did you ever imagine that demographics could be this deadly? See you in the next one.